Hello everyone. Today I am going to explain the contiguous array problem from Leetcode. So the easiest solution to this is just linear n square approach. Let's look at the problem first. So the nums array is given and we need to find the maximum length of contiguous subarray with an equal number of zeros and ones. So what we know is that either 0 or 1, only two possibilities in the array. Secondly, we need to find such an array that has the maximum number of zeros and ones. So in this input sequence, we know that 0 and 1 both are equal and the length is 2. So we need to return the length of the subarray. Firstly, we don't need to have any indexes. We don't need to know. We don't need to return any indexes. We definitely need to know the length, the indexes, so that we can find the length. Length is a property of index. Like we need indexes. In this question, in this example, we can see that it can be either of these, either this one or this one. This one, these two. Yeah. So now that we know this, we should also look at the constraints. Constraints are important. The length can be max to max 10 raised to 5, these many number of elements. Okay, now that we know this, the interesting solution to this, let's come directly to that. What is the interesting solution? So what I found is that I wasn't able to solve this at the first go, but after understanding the solution, what I found is the perspective to look at it. That is something I think is important. So what I found is the properties. Okay, so the first property that is important here is the way we represent each of the zeros and ones and how we keep track of them. That is the data representation. The data representation is important. The way we are representing data, that is, given an input sequence of zeros and ones, whatever number of zeros and ones, we need to find the maximum length. Now to get this maximum length, how can we represent these zeros and ones in such a way that we can keep track of them? That is, at every point we can look at multiple elements. When we are traversing, we can maybe use a different loop and then have it as, but it's not going to be a linear approach. We found the n square approach. We know that we'll find every subarray, every possible subarray. The linear approach is at the point which we are standing, at the point which we are looking at the element, at that point, how can we keep track of the zeros and ones that we had previously? Additionally, how can we use that information that we have kept in a data representation that we are choosing? How can we use that information to get the lengths? Okay, so this is an important attribute that we must think upon whenever we are solving. Second point is that representation. The representation, whichever we choose, should be capable of getting the lengths of this, because that is our objective, right? We need to find the lengths. So that representation should be capable of getting the lengths. And the third and very important, or let's say this solves the problem, that is the property. We'll look at it at a later stage. Let's look at the solution, what Leetcode says, has found in its editorial. So what it says is, let's say we are given an array of some zeros and ones. What we do is, for every one that occurs, we add 1 to it. We add 1 to the count, because this is not a typical sum. a typical sum would be just adding these ones and zeros, but what we are doing is we are going to add 1 to that count whenever we reach a 1, and we are going to subtract 1 when we reach a 0 with the count. Secondly, what we will maintain is our max length at every possible index, wherever we are. What we will know at that point is the max length at that point up to which, so we already should know that max length. Okay, that is the approach. Now this plus and minus 1, this thing we can represent it more beautifully here in this manner. Let me show you. See, at this point when we are at the 0th, let's say at 0th, what's gonna happen? We know that we got a 1. For a 1 we add 1, so we added 1, so we reached somewhere here, or let's keep it a bit below because it's going to go ahead. So we have added 1 and the sum. Okay, an important point is that we'll start the count at 0. Why so? That is the most balanced position actually. That is when you don't have either zeros or ones at that point. So at this point, let's say before this 0th index, we don't know the number of zeros or ones, so what we assume is they are equal. That is equivalent. No zeros and no ones are also equal, isn't it? It's an equal position, so that is going to be our 0. Okay, then we got a 1, so we added 1 to that count was 0 at first, we added 1, we got a 1. Next we added 1 again for the next index, we reached 2. Second count equals 2. After that we again added 1 for the next index, so we got a 3 as a count. So 3, yeah. Then we are going to subtract a 1 for the occurring 0, so it's going to come down here and the count will again become 2. Okay, then we'll get a 1 again, so now we are going to add it again, so it's going to be somewhere here. 3, again a 1 occurred, so now it's going to go a bit ahead here, so let me make it a bold line, and now this is going to be 4 as a count. After this we are going to subtract 1 for each of these, so it's going to come here, and then come here, right, at this position, at these counts. Okay, so now from this representation we can have a profound realization of the third property that I was saying. Okay, let me reveal it after a few moments. First, let's look at what we need to do for representing and keeping track. So how do we represent each of these zeros and ones so that we can keep track of them? So for that, the representation that we are choosing here is a two tuple where the first index is going to be our count and the second index is going second part of that tuple is going to be the index at which we got that count. So if we had this representation, right, so for every possible, what we are going to do additionally, it's important to know why we are going to do what we are going to do ahead. Now see, now if you look at this diagram from this of this array, you can see that the maximum length of equal zeros and ones is going to be the longest difference, that is from this point to this point, right? Can you find that? Because at this point, the count at this point, we found that the count was 2, right? And after going through some places, it again reached a point 2. Though it had a 2 somewhere here, this was a local solution, we can see. But after we have completely traversed the input, we found that this again our solution, right? The same count. So at this point, we have found the last occurrence, isn't it? The last occurrence of this count. Similarly, this was our first occurrence of the count. So this distance that we found, this is going to give us the longest possible equal zeros, right? So that is the reason my third and important assumption, important property was the first and last occurrence. So first and last occurrence of that count should ideally give us the desirable answer, that is the max length. So we can go through it through an example as well. So this example as well. So what we'll keep here, at the start we know that the index is nothing, right? So at this point, additionally, what we also know that there are no zeros and ones, yet we haven't looked at any of the zeros or ones. So we are already at the balanced position. No zeros, no ones, neither addition nor subtraction. We aren't adding or subtracting anything. We are at the 0. So that's why the count will be initialized at 0 and the index will be -1. Okay. So the count will be 0 and the index will be -1. Now, then when we reach the next index, we are traversing the whole array. So at 0th index, what we see is that the count will increase. The sum, that is the count, is going to increase. We had initialized it at 0. We had initialized it. Now we'll increment it by 1. Add 1 because we encountered a 1. And at which position? Now this count, again additionally, how are we also keeping track of the first and last occurrence? Now that in this structure, in our structure, what we are saying is that we are only going to keep the first occurrences of each of these counts. First occurrences. Okay. So now that we have the first occurrence of this 1, we are going to keep 1 and the index at which it occurred. So it's going to be 1. Next, let me write this here so that I don't need to go ahead. Okay, just assume that after this I'm writing it here. Okay, so at this index at 1, again we received a 1. So now the sum is going to be 2. Now 2 has not occurred anywhere, so we are adding it here. 2 and the index at which it occurred, so that is 1. Index 1. Then again we are going to add 1 for a 1 at index 2, which is going to make the sum 3. Now is 3 anywhere here? No. So we are again going to add 3 here. 3 comma at the index which it occurred 2. Then again we are going to subtract 1 because we encountered a 0. Now subtracting 1 should return the count back to 2 because we were at 3. Now it becomes 2, but we already have 2. So now at this point onwards, we won't update this. What we'll do is we'll check whether the max length, we are already going to keep the max length at 0 firstly. Okay, the equal zeros and equal ones, that sub array's length, that will be 0. So but at this point we encountered that this was the first occurrence and we have got another occurrence. Another occurrence means the same thing as this one, this the thing. Now we don't know whether it is our last occurrence, but we know that it is something, so we must keep track of that. So what we'll do is we'll get the max length and we'll subtract the current wherever we are, that position 3 subtracted by the index which we found the count. Here too we found the count as 2, and at index 1 also we found that count was 2. So what we'll do is 3 minus 1, which will be 2. Now is 2 greater than this max length, that is our previous one? Yes, it is. So we are going to update this to 2. Okay. After that we are going to go to the next index, that is 4. Now at 4 what we found is again a 1. Now we again reached 3. Now 3, we already have 3. Now this is going to be our first occurrence of 3, right? So now what we can do again is subtract the max length, that is the index, that is which is at 4. So 4 minus 2, this index should give us 2. But now 2 is already the max length, so it is not greater than that. So we don't need to really update that value. Now we'll again go at the next index. At next index again we found that we are going to add 1. Now 3 plus 1, so it's going to be 4. Now is count 4 available? No, it's our first occurrence actually. So we'll keep this first occurrence of 4 with the index at which we found it, that is index 5. Okay, we kept that. Next, now we go at 6. Now this will become 3 again. Now when this becomes 3, we know that yes, it has already occurred at index 2. So 6 minus 2 is going to be 4. Now that 4 length, is 4 length greater than our max length? Yes, it is. So what we have to do? We must update this to 4. That is going to be our max length. We got that, and we go ahead. We go ahead on 7. Now here again this 3 will be subtracted and become 2. Now at count 2 we already have a first occurrence of 2 at index 1. So what we should do is we should again subtract 2, the current index subtracted by the first occurrence of that index, that will be 7 minus 1, so that is 6. Now length 6, yes, 6 is greater than the previous max length, so this is going to be 6. So at the end of the traversal we should get the maximum length of that zeros and ones. This is how we should solve this issue. This is how we solve this problem. And this structure that I was showing here, this is actually your map in your programming languages. That is where we are keeping the index as well as the value. We want to manipulate both of them simultaneously. So that is it. Hope you found it useful. Okay, thank you so much.